Welcome to the Developer Service YouTube channel. On today's episode, we're going to be building a space shooter game with PyGame. As usual, you can also find this tutorial on the Developer Service blog. I will leave a link in the description for the blog post and also for the source code. You can see here the game in action. So we're going to be building a very simple space shooter. It has the aliens coming down, it has the player that we can move, and the projectiles that we can fire to kill the aliens. Of course, if the player gets hit by the aliens, then the game is over. So let's see how we can now build the game. So as usual, we're going to be using PyCharm to build our code. I've already have the code here prepared. In terms of requirement, we're only going to be needing PyGame. So let's install that now. Do the pip install and the requirements. As you can see, I've already installed, so we do not need to do that. So with the requirement now installed, let's take a look at our code. First, let me give you a rundown of the game structure or the code structure. So we have a player class that is responsible for the player, and we have the player PNG, which is the design for the player. Then we have an enemy class, which is the aliens coming down. Also, we have the design for the enemy. We have then a projectile class, which is responsible for the missile that the player can fire, also with a visual. And finally, we have our game logic, or our game class, where all the game logic is included, including the initialization of the PyGame and all the necessary game logic. So with that, let's start with checking our player class. So to create our player class, we import the PyGame, of course, and we also import the projectile class that we'll see later on, because the player can fire the projectile. So we define the player class as being a part of sprite from PyGame. That means that we can use the PNG. We initialize our class, so we're loading the image and converting to an alpha, so it can be transparent. We are defining the initial position, which is at the bottom of the screen and center. We are defining the initial speed, which is a parameter that we pass when we create an instance of this class. Then we're defining some internal variables, which is the shooting delay and also the last shot. What this allows us to do is to prevent the player from firing constantly, and that only fires from time to time. We're setting up also player score, although we're not going to be using it in our current implementation of the player. That's the class initialization. Then we define an update class that it's called from the game logic, and that receives also the current projectiles that are in the game. We're checking the keys that have been pressed or not, and then we're establishing if it's the left arrow or the right arrow. We're moving the player in the corresponding direction by reducing the X position or increasing the X position with the speed. In case the space key is pressed, then we're going to shoot a projectile, and we're passing the list of the already existing projectiles, and the shoot class we are defining later on in the player. And of course, we need to make sure that when we're moving, that we're keeping the spaceship from the player inside the rectangle. So we're using that with the clump IP and the get surface from the current display. That's all enabled by using the sprite class to make sure that it stays inside the screen boundaries. Like I mentioned, when you press the space key, we fire a projectile. And so we are using what we have defined before. First, we are checking the current time. And if the current time in relation to the last time that it was shot has not been passing by the delay, so meaning if the last time we fired is too soon, then we're not going to fire. But if that is possible, then we're going to be creating a new projectile, meaning creating a new instance of the projectile class. And we're going to position it at the center and at the top of the player rectangle, so it comes firing from the top of the player. We add that to the existing list of the current game projectiles, and of course we update the last time that we shoot, so that we can again do the validation when next time we try to shoot. And of course we return the player projectiles to the game class so that it can process the game logic. We'll see calling the update and the shoot class later on, how it is called in the game logic. Next up, we have our enemy class. So we're importing random, and that's going to be used to position the enemies in a random position, and of course also the PyGame. As in the player class, the enemy class inherits from sprite. Same principle, we're loading our PNG image, converting to alpha to be transparent. We're positioning an initial instance of one enemy. So one enemy are currently positioned in a random position from the top and also in a random position from the left to right axis. We're defining the initial speed as before, and we're setting some local variables that we are going to need later on by defining our screen height that we receive from the game, and also the last time that the player position or the enemy position was updated, and also the update interval. This is to allow us to control the rate of descent of the enemies as they go from the top of the screen to the bottom of the screen. As with the player class, there is an update class that is called from the game logic, and that pretty much is similar to the shoot class of the player. In this case, for the enemy, we're also checking the time. We're going to see the last time that we updated the enemy's position, and if we can update after that interval, we're going to move one of the enemies down. Keep in mind we have several instances of the enemy class later on in the game, so we're moving the enemies down by the speed. And of course updating again the last time that it was updated, and we're doing one final check, which is if the enemy has gone off the screen, meaning if the rectangle position of the bottom has passed the screen height. That's why we're doing the screen height in the top. If that has happened, if the enemy has gone off screen, then we're going to kill this instance of this class, meaning that the enemy dies and gets taken off to the game. Next up, we have our projectile class. This is responsible for the missile that is fired from the player. Of course, importing the PyGame. Sprite class as before, inheriting. We're again loading our PNG file and converting to alpha to be transparent. We're setting our initial position. As mentioned, it comes from the position that is passed in this case, which is X and Y that comes from the player when it's the projectile is shot, and it's in from the top of the player. We're also setting it the speed. As the enemy and player class, there's an update that's called by the game logic, and again this just means updating the direction or updating the X position, the Y position of the projectile. In this case it goes up, that's why the minus. Then we are detecting if the projectile has gone off screen, and just as similar. So if it's not colliding with the inner game rectangle, and as before, we're just going to kill the projectile and it gets taken out of the game. Finally, we have our game class, which is responsible for our main game logic. So again, we're importing random, PyGame, and importing obviously the enemy and the player class. We do not need to import the projectile, because as you remember, that is imported in the player class, because it's the player that is responsible for firing the projectile and keeping track of it. So we initialize the PyGame. We'll create our game window with a size of 800 by 600. We're going to set in the title, just space shooter, and we're creating an instance of our clock so that we control the frames per second or the frame rate at which the game gets updated. So next we have a spawn enemies method that receives the screen within the screen height and also how many enemies you want to create. So we are creating an iterable in terms of the number of enemies, and we're creating one enemy. We're giving it the speed of 5 and passing the screen within height that the enemy class needs. And the most important thing is afterwards we are checking if we are creating an enemy that the position is colliding with an already existing enemy. So meaning we do not want overlapping enemies, we want them to be spread out according to the X and Y axis. So we are checking for that collision by using the sprite collide of this particular enemy with the list of enemies, and the list of enemies is an instance inside the game logic that we see later on. If it is collide, then we're just going to try to generate a new position, and we'll do this, we keep repeating this until we find positions for all the enemies inside the game. If the position is valid, if it's not colliding, then we can add that enemy to the enemies list, and that concludes the creation of our enemies. Next up, we have the method that is used to check the collisions between the different game objects, called check collisions. So initially we are checking the collisions between the player projector and the enemies by using the sprite group collide. That's another advantage of having all of the game objects being part of a sprite. So it receives the player projectiles and the enemies, and we have do kill from A and B, meaning kill player projectile if that gets hit, or kill the enemy if also that gets hit. So then we are checking the collision between the enemies and the player, meaning if one of the enemy ships has hit the player, we're only killing the player if that is the case, because the enemy of course survives, but the player gets killed. And if that is the case, we're making sure that our running variable that we have later on inside the game logic, that is defined as global, so that we can change its state here. And then of course we set that running to false, because if the player gets killed, then the game is finished. So now we start creating our main variables for the game logic. So we are creating the player spaceship, and for that we create a sprite group that is a single group, meaning it will only contain one sprite, which is the player, which should then create an instance afterwards, and we add to that single sprite. Again, using the sprites allows us to use things like the group collide and several other helpful methods that makes our game logic much easier to implement. Then we do the same for the projectiles. We create a player projectiles list, which is just a group of sprites. We create also a group to store the enemies, a sprite group, and then we call the function that we saw earlier, the spawn enemies, passing the screen width and height, and also the number of enemies that we want, in this case 10, so that we generate our enemies. So next up we have our main game logic, or main game loop. So as we saw, we have a running variable that determines while the game is running, and while the game is running we just keep repeating this loop. First we are lighting off the events. The first event is in case we close the window. If we close the PyGame window, then of course the game finishes by turning the running variable to false. We are calling the check collisions, which is the method that we implement before to check the collisions between the player and the enemies, and also the projectiles and the enemies. So checking that those collisions. Then we have the calling to the different update methods. So we're calling the update for the whole player group, which in this case is a single group. So the fact that we are using the sprite group, that means that when we call an update on the group, it calls the individual instances that are inside the sprite group. It calls this update method. So calling the update on the group means calling the update on the player class in this case. We do the same thing for the enemies. We call the update method there, which is update set position, and we're also calling an update on the projectiles, that will also update the projectiles position on the screen. Then we are drawing our game objects. We start by filling the screen, and we draw all the instances of the sprite group belonging to the player, in this case single instance again, so we're drawing the player in this case. We're drawing all the instances of the enemies, and we're drawing then all the instances of the projectiles. Again, the fact that we use sprites and the sprite groups allow us to simplify greatly this logic by just calling the draw method inside the group, and the group calls the draw method inside the sprite class, and the sprite class automatically draws the game object in the screen. We update the display so that all the positions and the drawing gets updated, and we are using our clock with a tick of 60 to control the frame rate, which in this case is 60 frames per second. And if we have exited the running game loop, then of course we are quitting our game and we finish the execution of the PyGame. So let's now see our game in action. Let me run the main game file. Just give it a couple of seconds for the game to start up. As you can see, we have our space shooter game running. I can use the left arrow to move to the left and the right arrow to move to the right from the player. As you can see, it stays inside the screen boundaries. I can fire by pressing the space bar. I can fire one projectile, it hits the enemies, hold the collision detection. I can fire multiple, but as you can see, even if I keep the space bar pressed, it does not fire simultaneously. It has that delay that we saw before. And I can try to kill the enemies, trying to survive, and you see when the enemy gets hit, then the game, or when the enemy hits the player and the game finishes. We can of course put a game over the screen or something like that, but just to show you what happens. And let me run the game again, and let me show you what happens now when we kill all the enemies, which pretty much the game ends. But as mentioned, we could have created either an in-screen game when the player dies, or also in-screen screens for when the game ends. But as you can see, this is our implementation of the space shooter. Very simple implementation, but the fact that we have the different classes and we are using the sprites allows us to simplify a great deal the game logic. So thank you for watching. Please do like the video if you like the video. Subscribe to the channel for more updates about Python, Django, PyGame, and all things related to Python. Again, thank you for watching, and until the next time, happy coding.